is acting on block A are force F, which is external force which is being applied on block A, and the friction force F dash R. And since the block A is at rest, it is not moving, so F dash R must be equal to force F. So in this case, the coefficient of friction mu is also called mu s, that is static coefficient of friction. And the term static here indicates that there is no relative motion between the surfaces, that is, surfaces in contact are at rest. Now let's see what is kinetic friction. If there is some relative motion between two surfaces in contact, the friction force which is acting between these two surfaces is called kinetic friction, and its value is equal to mu k into n, where mu k is the coefficient of kinetic friction. So to understand this, let's take the same example. So suppose we have block A and block B, and a force F is acting on block A, and because of this force, the block A starts moving in the right hand direction. So the friction force which is acting on block A will be in the left hand direction. So the forces acting on block A are F, which is external force, and friction force FR. Now since in this case the block A is moving with respect to block B, we call the friction force which is acting on block A kinetic friction. And its value is equal to mu k into n, where n is the normal force acting on block A, and mu k is coefficient of kinetic friction. Now again, the value of mu k will depend on the nature of surfaces which are in contact. So for a given pair of surface, there are two value of coefficient of friction. One is mu s, which is coefficient of static friction, and mu k, which is coefficient of kinetic friction. So now if we write the equation of motions for block A, we can write that F minus Fr is equal to ma, where m is the mass of block A and a is the acceleration. Generally the value of static friction is slightly higher than the value of kinetic friction, but if nothing is specifically mentioned, then we can take the value of static friction as equal to value of kinetic friction, which will mean that mu k is equal to mu s, that is, coefficient of kinetic friction is equal to coefficient of static friction. Now let's see what is the total reaction force acting on a surface. The total reaction force acting on a surface is the vector sum of normal reaction and the force of friction acting on the same surface. So suppose there is a block which is kept on a surface, and the block is moving in the left hand direction. So the force of friction acting on the block is Fr, which will be in the right hand direction, and the force of friction acting on the surface is again Fr, which is acting in the left hand direction. Now here n is the normal reaction acting on the block, so the total reaction force, that is S, which is acting on the block, will be equal to vector sum of normal reaction, that is n, plus friction force, that is Fr. Now if the angle between normal reaction and total reaction is lambda, then this angle lambda is called angle of friction, and the coefficient of friction between these two surfaces, that is between the block and the surface, mu, will be equal to tan lambda. Now we'll see how to find the direction of friction force. To find the direction of friction force which is acting on a surface which is in contact with some other surface, first we'll assume that the surfaces are perfectly smooth, that is, there is no friction between them. Then we'll see that what is the possible direction of relative motion between them, and then the direction of friction force will be such that it will oppose this relative motion, and this friction force will act on both the surfaces. It will be equal in magnitude and opposite in direction. Now we will start the chapter application of Newton's law. So first we'll see a typical pulley system, and then we'll discuss how can we apply the Newton's law in a pulley system. So this is our typical pulley system. You can see a pulley here. This is your pulley around which a string is attached. This is string, and on the both ends of the string there are some masses attached. This is mass m1, sorry, mass m2, and this is mass m1. So this is our typical pulley system. Now let's go through various assumptions and facts about the pulley system. The thread used in the pulley system is ideal thread, that is, it is massless, it is inextensible, and it is flexible. Also, the ideal pulley system is frictionless system. Now the same thread bears the same tension. So for example, here we have a pulley system which has one thread. Now the tension in this thread will be equal to T, and the same tension will be there throughout this thread. So tension here will be T, and so is the tension here. So as you can see that the value of the tension remains the same throughout the thread. Now in any part of the thread, the tension is applied at both the ends and towards the center of that part. So if you take any part of the thread, suppose we take this part. So this is the part of thread that we have taken. So the tension will be applied at both the ends. So a tension will be applied at this end as well as at this end, and the direction of tension will be such that it is directed towards the center of this part. So a tension T will be applied at the end A, and the tension T will be applied at end B. As we have already seen that the same tension runs through the entire thread, so the value of tension will be same, and this tension force will be towards the center of this thread. The thread tension acts on the object with which the end of that part is connected. So in this pulley system we have two objects, M1 and M2, which is connected with the thread. So the tension T will act on both the object. Now the thread is inextensible, so the total thread length remains constant. Also, the thread cannot bear negative tension, that is thrust, while the rod can bear tension as well as thrust. Now let's see a solved example. Now we need to find the acceleration of the center of mass in the given pulley system. So first let's see the pulley system. So here we as you can see that there are two masses attached with this pulley system. One is M1 and other one is M2. So all the forces which are acting on these two masses are shown here. So if we take the mass m1, a tension force T will be acting upwards, and its weight m1g will be acting downwards. Similarly, on mass m2, the tension force T will be acting upwards, and its weight m2g will be acting downwards. So let's assume that the pulley is moving downwards in anti-clockwise direction, that is, mass m1 is moving down and mass m2 is moving up. So if we write the equation of forces for mass m1, since it is moving downwards, we can write that m1g minus T, this is the net downward force acting on the mass m1, so this must be equal to m1 into a, that is mass time acceleration. Similarly, net upwards force acting on mass m2 is T minus m2g, and this will be equal to m2 into a. So by solving these two equations, that is equation 1 and equation 2, we can get the value of acceleration and tension T. Now we need to find out the acceleration of center of mass. So we already have the value of A and T. Now if we take this both m1 and m2 as a system, the net force acting on the system is tension 2T and the weight, that is m1 plus m2g. So the acceleration of the center of mass will be m1 plus m2g minus 2T is equal to m1 plus m2a, where a is nothing but acceleration of center of mass, that is AC. So from here we can get AC is equal to g minus 2T by m1 plus m2. Now we already have the value of T, so from this we can get the value of acceleration of center of mass. Now we'll see how to use thread constraint in solving problem based on pulley system. As we know that the total thread length remains constant in a pulley system. So what we do is we take a fixed point as reference and we measure the length of various part of the thread with this reference point. Now the acceleration of different objects which are connected to the thread are taken away from this reference point, and the double differential of their displacements from the reference point gives their acceleration. So what we do is we write the total length of the thread in terms of these displacements and differentiate it twice to get relation amongst various acceleration. Now let me explain this concept further. So as you can see here we have a pulley system. One end of the thread is attached to the ground and it is immovable, and to the other end a block